Hello, my name is Karel Klaassen. I'm a Senior Applications Engineer for Pressure Sensors at Melexis. Today I would like to give some more information about the MLX90818, a packaged harsh media absolute pressure sensor covering applications from 1 to 5.5 bar. Topics that I will cover in this video are the product's block diagram, PCB design and module design to fulfill the toughest harsh media requirements. Let's start with the block diagram. The MLX90818 product consists of two silicon dies, a MEMS absolute pressure sensor and an interface IC. On the left side of the block diagram you can see the sensing element. This is a piezoresistive MEMS sensing element configured as a Wheatstone bridge. The differential output of this sensing element is connected to the analog front end of the interface IC. In this analog front end, the offset and gain are compensated. The amplified differential signal is going through a multiplexer to the 16-bit ADC. Other signals that are multiplexed to the ADC are an on-chip temperature sensor signal, the external supply signal, and other signals that are used for diagnostic purposes, and optionally an NTC signal. We will come back later on this topic. The analog pressure front end is calibrated in such a way that over the complete temperature and pressure range, the signal will always be in the measurement range of the ADC. The 16-bit pressure signal is compensated over temperature and pressure linearity using the on-chip temperature reference signal and digital calibration coefficients that are stored in the EEPROM memory. Due to the use of the microcontroller-based architecture, there is a high flexibility in the calibration options, allowing up to 10 temperature and pressure combinations in the calibration process. The use of this architecture in combination with an optimal sensor design and a robust package results in a high output accuracy up to 0.5% full scale. The compensated pressure in combination with the internal temperature and, optionally, the linearized and factory calibrated NTC information are placed on the send output using the send driver. The microcontroller also handles all diagnostics to ensure a safe and reliable operation of the system. Of course, this product also contains all the required protection circuits needed for an automotive pressure sensor in under-the-hood applications, like for example overvoltage and reverse voltage protection. Let's discuss the NTC input in this product, as I mentioned previously. We offer the option in the MLX90818 to have a linearized and calibrated NTC signal available on the send output. The calibration of the NTC is handled completely at Melexis and requires you to only connect an NTC between the input pin on the chip and ground in the module. In the block diagram of the NTC signal chain, you can see the external NTC in the bottom left corner. An NTC is by nature a resistor which has a very non-linear resistance characteristic over temperature. The NTC is supplied by the chip's analog regulator through an on-chip resistor RS. This circuit forms a resistor divider that already performs a first level of linearization. The output of the resistance divider is fed into a unity gain amplifier connected to the 16-bit ADC. In the microcontroller, we compensate the temperature ADC values using a third-degree polynomial to further linearize the NTC signals and to cancel out any influence of temperature on the on-chip interface circuitry. Calibration coefficients for this compensation are stored in EEPROM. In the final step, the compensated ADC values are matched with their corresponding row in a lookup table stored in ROM. This lookup table contains two columns. The first one has a list of ideal compensated ADC values, and the second column holds their corresponding 12-bit send output temperature values. Using this lookup table, we can now match the compensated ADC value with its corresponding row and as a result also with its correct output temperature signal. All of these NTC compensation steps finally result in a send output characteristic according to the standard with a ±1 degree temperature accuracy. One of the big advantages of the MLX90818 is its size. Thanks to the 4x5mm footprint, small PCBs in the modules are possible, allowing an easier module design. From an external components point of view, only 3 capacitors are needed. 1 capacitor on the supply, 1 on the output, and 1 on the NTC when it's used. However, for optimal EMC performance, it is recommended to use 2 CRC networks. 1 on the supply and 1 on the output. We can support you in reviewing your PCB schematic and layout, taking your specific EMC requirements into account. Another key feature of the product is its harsh media robustness. The product is designed in such a way that no corrodable metals are exposed in the cavity that can get attacked by a harsh media chemical environment. The solder joints between the DFN package and the PCB can be easily protected, for example from moisture or chemicals, using a protective coating. More information and details on the topics that were presented in this video can be found in the datasheet, which is available on our website. Thank you for watching and stay tuned in our channel, as there will be more similar products coming soon.